Hello, my name is Sky, and I'm going to be talking about how stress impacts your brain, specifically looking at the hippocampus, which is important for many things like memory and learning and emotion, daily life. And there's this phrase when talking about stress that stress shrinks your brain, and that's actually not entirely false. What isn't known as much about that is how stress shrinks your brain. And there's many theories, which is kind of what my paper explores. But this is more important because looking at and having a bigger understanding for these things can help people who have that hippocampus shrinkage and people with depression and PTSD and chronic stress in possibly advancing prevention and treatment and going forward in general. So my paper, it was done by Schoenfield and his colleagues in 2017, and the big question was, does chronic stress lead to the hippocampus volume loss due to neurogenesis loss alone, so the growth of new neurons alone, or are there multiple factors at play with that stress? So a lot of people thought that because neurogenesis is helpful and the growth of new neurons helps maintain the size of the hippocampus, that is what led to the decrease. So they used rats, Long Evans rats, and they split them into two groups. So one of the groups experienced chronic unpredictable stress, restraint stress, over the course of 4 weeks, and each group had a control group. And that was used to model long-term stress that we experience as humans. And then the second group was given this drug. They were not stressed, but they were given a drug, and it was called temozolomide. And what this drug did was it prevented new neurons from being produced. It blocked neurogenesis. And the separation let them see if the new neurons alone and the inhibition of that could explain the shrinkage, or if there was more factors at play with just the stress. So for the drug group, for the group that they were looking at, they measured it at 4 weeks, at 8 weeks, and at 16 weeks using an MRI. And then they post-mortem looked at the cells using histological analysis under a microscope, kind of just conformationally as a cellular level. And what they saw was they looked at 3 regions of the hippocampus: the dentate gyrus, the CA1 region, and the CA3 region. What they saw is at that 4-week mark, there was some shrinkage at the dentate gyrus region, but not really much in the CA1 or the CA3 region. And then at 8 weeks and at 16 weeks, they saw some more in the dentate gyrus as well as the CA3 region, not as much in the CA1 region, but there was obvious shrinkage as we kind of expected. And then alternately, looking at the stress group, there was this widespread shrinkage in all 3 of the regions. It wasn't localized, and kind of what they drew from that was that neurogenesis alone can't be the sole cause of the hippocampus shrinkage, because stress is obviously, widespread and using all different processes, whereas neurogenesis is slow and it's localized. So this shows that the stress likely uses many systems, uses hormones, glucocorticoids, glial cells, dendrites, can affect blood, uses blood flow. It's all these different systems, and it's not just the neuron growth that causes the shrinkage. And the difference helps explain why things like antidepressants, which are the primary goal of them is to boost neurogenesis and to increase that cell growth, doesn't fully reverse the stress-related brain changes that you're experiencing, because stress is literally reshaping your brain in a rapid way, but neurogenesis is acting slowly and gradually. Overall, it kind of just shows that, yes, neurogenesis reduces your hippocampus volume, stress reduces it, but they have distinct pathways and timelines. Stress is rapid and widespread, and neurogenesis is more gradual. Kind of what stood out to me about this was kind of how quickly stress can cause brain changes, and how that actually physically is happening, and understanding how that could lead to different treatments in mental illness. And then if I were to follow up on something, I think it would be interesting to look at how your brain recovers and how neurogenesis is after stress is either relieved, or looking at acute stress versus chronic stress. And I just think that could be really interesting. But overall, I thought that this paper was super interesting. And yeah, thank you.